Hi everybody, this is Tom, and this is a little quick look at what goes on under the hood when we start to create um, a scanner program that will read an answer sheet. I've been working on the new version of the debate score sheet, and so let me load one of those in so you can see what it looks like. Here's my latest draft, and it's not the same as the last one Daniel saw, but that's okay. It's something I've been working on here. Here's the problem. Here we have the debate score sheet, and it's a little different than the last ones we've had. This one has kind of these little black bars over here. The basic strategy is that I take the black bars. This big long one here at the top will be especially useful to do things like figure out how large the scaling was. If the copier shrunk it or grew it, this will give me the scale. It'll also give me the angle or the slope of the sheet. Those are usually somewhere between -2 degrees and +2 degrees. Most of them are around 0 on most good scanners. And I'll get that off of that top square. Then each of these squares below it, then this bar here, notice beside it says, and I don't know if you can see this, it says affirmative team. So this is the team number entry. And beside this are 10 circles, 0 through 9. Same thing over here. So what the plan is that I detect where these black bars are, and then I use the size of the bar and the location of the bar to calculate out on the side here where each of these cells are, each of these circles are, and then I look to see how many pixels each of them has colored in. I have to calculate, or I have to figure that the darkness is going to be a little bit darker than what's there with nothing, and then we have to detect which one has been colored in. My first challenge though on this new score sheet was finding these black bars. Normally what I have done is kind of moved in from the edge with a device that looks and looks and looks until it hits something and then it stops, and starting from a specific spot on the edge of the page. But here we've got text kind of mixed all through the whole sheet, and that is not possible. So I had to use plan B, which is to create a new routine, and so that's what this under the hood business is. I'm going to show you a little bit about how we did that. One of the things you may have used that will give you some insight on how we do this is if you've ever played with paintbrush and you've used a flood fill. Let me just demonstrate that real quick here. I'm going to pull up a graphics program, and here is paint.net. And for some of you that ever want to edit something like a spreadsheet or edit something like a score sheet, paint.net is my first choice. I love this program. Let me load in some kind of a recent file like the one I've got in there. Okay, and so now if I zoom in and look at one of these bars here, I can pull up my tools, and here's my color tool and my other tool, and I can grab a tool. Looks like the paint bucket, and you've known this since the first Macintosh was out, and I can pick a color to paint with, and then I can specify a tolerance on that, and we'll set a fairly moderate tolerance and then paint this black area there red. And what that does is it takes the place you click on, and then it looks at all the neighboring cells and paints them red, and keeps looking until it runs out of the original color plus or minus the tolerance, whatever the tolerance is. And so the flood fill then can be used to color a region. Well, basically instead of coloring the region, I just gather up all the points by using the same technique. I take a point on the screen, and then I look at all the points around it and see if they're the same color, and then I gather those all up into a collection of points, and that becomes my blob, my black bar. And then I can see beside it, I can then do a rectangular area around that. And what I'm going to do then is I'm going to look with, let's see, let me do a brush width of 1 and make a rectangle. Okay, so now basically what I'm going to do is I'm going to measure out here, and I'm going to look at all the points within this kind of a region here and count the pixels. And if there are enough black dots in there, we're going to figure out that which one of those three has the most black dots. Now, if you ask yourself, well, the A and the B and the C are going to be black dots in there too, you're right, they are. And with a little luck, those three letters, and it doesn't look like they'll be too bad, one of those may have more dots than the next. So if you don't fill it in, there will be one there that will register as the marked answer, even if they leave it blank. So that's a problem there. Same thing over here, 2 through 7. We have these little circles over here that we're going to look at later. And each of those then will have a black bar beside it. That'll give me a scale, a place to start. And then we'll measure out from this a specific fraction of its height or something like that. I will express the distance of the center of this thing away from the top and bottom corners of this thing, and I'll calculate how to get this rectangle here, and I'll look in this rectangle and read the number of dots. Okay, but that's not the problem I've been solving here the last day or so, but that's the strategy we'll use to add up the points. Okay, so now we're back in this program here, and basically I looked at this and I thought, how can I go through all that text in that whole thing and find those black bars that are married with all the text and mixed right in the middle of them, and pick up the black bars but not pick up the text. And that's the problem I was trying to solve. Well, let me show you the routine I've got and show you a little bit, talk a little bit about it. Right now it's in a development stage, so this is being run in a special program that's helping me to develop the program. And so you can see here now it searched this bitmap over here, this graphic, and to show me the results I had it create a second graphic over here, and you can obviously pick up the corresponding points over here. Let me zoom in on that and show you kind of what I did to find all those black areas on there. First thing I did was I went through the whole document, and I looked at a grid of points, an array, a matrix, whatever you want to call it, and these are about 2/10 of an inch apart, vertically and horizontally. And I did the entire sheet. Now, if 2/10 of an inch, what you would have then is in 8 inches across the page, you'd have 40 dots across and about 50 dots or 60 dots vertically, or about 2,000 dots. And so as we scale back from this thing, there would be 2,000 dots in this document from top to bottom and left to right. Then I go through each of the dots in there, and I put the flood fill, the detecting the neighboring colored areas, and I look around at all the dots around that one, and if there's nothing there, we dismiss that point as not being part of a square. However, when I try the flood fill with one of the squares that is on top of one of the black areas, it fills that in. It gives me all the points in that area, and then then I can color them to show that I succeeded. So any of these dots here, if I could have known ahead of time where the big black bars are, I could just go there and do a flood fill and find out exactly where they are. But because of the scaling factors and the tilt factors, we don't know precisely on the page where things may land. If this is tilted slightly, the bottom ones or the middle ones or something may be left or right of where I think they are going to be. So this is a very general routine. Basically, it took 5.9 seconds, and I hope to get that down under 4 seconds per page. And I will look at the entire page, and I will look at the locations of where those bars are. And once I have that, then it's pretty simple rectangular geometry to use the size of this and the location of this as a coordinate system origin, and just measure out to the side to get a coordinate that's based on that. And so we'll be using a system there like that to find our points. So that's kind of what we're looking at. Now let me show you some of the parameters I'm dealing with here. I'm going to redo my blob hunt a few times and show you some things. First of all, I have to throw away any piece of information I find over here that's not a big black bar. And so basically I do that flood fill thing. I look at all the points around the point of interest, and I bring back that collection of points, and then I just count the points. And if it's above a certain amount, then I color it in and say, yep, that's one of the big black blobs. And if it comes back with too few points, then I dismiss it and say, oh, well, must have hit a piece of text. If you look closely at this again, you see that if you look here, there's kind of a square right here, and there's kind of a diamond here. This square has actually hit a black point. There's a piece of text or something, probably one of the labels like digit 1 or digit 2 or something like that. It hit a piece of text there, but because that piece of text wasn't very massive, it didn't have a big black bar, it didn't record anything there, and it threw that point away and said, nope, nothing here. Alright, so I look at every point that in my grid, and if it's rectangular, there's black underneath that, and I should look around that to see if it's got any neighboring points, see if it has a chance of being one of those black bars. And if it isn't, if it's one of these green ones, it's not actually even in the collection. That didn't hit black. That hit white, probably. Okay, so now as I look at this, I can control a few of these variables. For example, the weight. So let me turn my weight down and let it find points that are less massive than the ones I'm looking for. Okay, so I'm going to redo this search, and there we go. And I'm going to rehunt it and see what I can get. Now it's going to let me find much smaller black blobs. And when it comes back, if you look at this, you see we have some writing up here. You see we have some arrows down the middle that showed up and some other writing in here. These are things that triggered it, that I happened to hit with my grid, and they were just big enough to be picked up by this routine. It also picked up all the black areas too. Let me turn that back up a little higher, maybe to 20 or to 18, 17. Run it one more time, and it's going to go back and look, and this time it's going to require a little bigger piece of black to turn it on. And I don't think we picked up anything there that time. Now the other thing that can happen is the grid spacing. I can control that. Right now they're 2/10 of an inch apart, 0.2 inches. What if I make the grid bigger, it goes faster. But then I run the risk of having my marks miss one of the big areas depending on the size. This time I'm going to run it with a spacing of 3/10 of an inch. And as you can see, it looks pretty good, except I missed the bottom left one. And if I look closely at that, I would find that the black, apparently the width of this just happened to match up with and fit between two of the dots on the grid, on the matrix. And so I have to turn that back down to make sure I don't inadvertently miss one. Okay, and so now I'm going to run it at 1/4 inch and with a blob size of 0.17, and the blob step is how much I'm trying to find. I'm sorry, it's how darkly it colors it, how close together it colors it. So now, with the grid spacing at 0.25 and the minimum blob size at 0.17, it missed the top left one. So I think I need to turn this blob, I think I had this at 0.2. So it missed it at 0.25, and I think I can leave that at 17. Now let's try it again. Okay, got them all again. So 0.2 works and 0.17 is enough of the size to work. I can make that a little heavier, I think. Let's do one more thing here. Let's turn the blob step down to 1. Let's set the grid spacing pretty tight. Let's set it down to a pretty small number. This is going to take a while. And the blob size down to 5. And now we're going to pick up an awful lot of the black things on the page, but it's going to take a long time to go through and do that. Now right now I'm not doing anything except looking at the number of dots in the collection. And the number of dots in the collection gives me a hint as to how, as to whether or not that's one of those locator blocks. Now, once I've described this, you can see some of the things that can cause problems. If we look at our score sheet, hopefully there it is. If we look at our score sheet, solid lines attached to the black boxes, because of the way that flood fill works, it would find those also. So I took the very simple step of just turning these into dotted lines. Same thing here. Then I can almost be sure, because the neighbors don't have black connected to black, you're alternating black and white. I won't find those, and they still serve the same purpose as the original solid lines. Now, the other thing is that when I find a rectangle and look at it, I have to make sure it isn't real dark. Because if somebody has a real dark circle with a real dark one in it, and then they shade that very lightly, it's pretty darn hard to figure out which one they shaded. And so, preferably, if the printer can do it, I prefer to have these a little lighter and have the so that we can actually tell which one they shaded in. Okay. The other thing was the size of these black bars. These were a little smaller and narrower and so forth. Turns out that I could easily set the grid up for this thing so that it would not ever miss one if I just made them a little wider. And so I made them all a little heavier and a little wider, and that meant that I could actually go faster if I can have a bigger target to hit with my grid of dots. Now, originally Daniel had a couple of little squares, one to the left of the ABC here. I decided I didn't need that. I was having trouble finding that short block of black over here, and I decided, well, hey, I can measure from the right or from the left. This black bar will locate for me the location of these or the location of these, and that'll work for me. So I'm going to just measure left with these and measure right with these. The other thing I changed from the original incarnation of this was that I added a space between each of the circles. They were touching, and technically I think that it's probably going to be a little better to find them if they're just slightly spread apart, and I was able to do that by tinkering just a little bit with the layout here, and there was enough room to put the spacing in here like this, and hopefully that will give us even more accuracy on the form. Overall, this looks like it's going to work. I'm not done yet. I have another couple of days worth of work on it. These are a pretty major project, and every time I do one I have to test and test and test and invent and test and invent. And so adding a new form like this is something that is liable to have 40 hours of work in it before I'm done. So kind of just thought you might like to look under the hood and see what I do as I work on one of these things. And this was just simply a documentation for a documentary film for your entertainment. I hope you enjoy it, and I'm making some pretty good progress. Now I have to work on the next piece, the next step, and find out how to scan these circles and things. So enjoy. Bye.